Now that we remember how to sketch our inequalities and find the intersections, find maximums and minimums, we're going to actually put that into practice with an application problem. So for this problem, what we're doing is we're going to pretend that we have a juice company. We sell a gallon of orangeade, which is made up of 2.5 quarts of OJ, 1.5 quarts of raspberry juice. We also sell berry fruity in the gallon, made up of 3 quarts raspberry, 1 quart orange juice. Okay? We have 150 gallons of raspberry and 125 gallons of OJ to make these two. So my goal is to figure out how do I maximize my revenue when I can sell a gallon of orangeade for 50 cents and a gallon of berry fruity for 40 cents. Okay, so this is my objective. We could go ahead and start that. We want to be able to make the highest revenue, whatever. So we're going to say we got 50 cents. I'm going to go ahead and call orangeade X. And I'm going to call berry fruity Y. So our goal is to maximize that. So then we have to build our constraints. How do we build our inequalities? So if I have 150 gallons of raspberry, where this one takes 3 quarts and this one takes 1.5 quarts. So I'm going to go ahead and convert my gallons to quarts by multiplying that by 4. So we got 150 times 4. So this is actually going to be 600 quarts for us. So I can use up to 600 quarts of raspberry. So that's going to be 600 is greater than or equal to, here we use 1.5, so I'm going to put 1.5x. And here we use 3 for raspberry, so I'm going to say 3y. So I can only use the 600 quarts of raspberry juice, and they each take this much. So we'll do the same thing for OJ. So we have the 125 times 4. So this is 500 quarts. So I'm going to do the same thing. 500 is greater than or equal to, so this one uses 2.5, and this one uses 1. Okay, so what we're going to do is these are my constraints here. We can also be under the impression that we're going to sell more than 0. So we're going to have more than 1 or more than 0 of each. So we're going to only deal with those positive values. So we're going to be here in the first quadrant. Okay. So what I'm going to do is I'm going to go ahead and I'm going to isolate y here. So I should have left myself a little bit more room. 600 minus 1.5x, 3y, and then I'm going to divide this by 3. So 200 minus, I'm just going to ask my calculator because my brain's a little tired, 1.5 divided by 3. So that is going to be 1/2 x, like such. All right. So our numbers are going to get pretty large here, so hopefully we can make that work. So here I'm also going to isolate my y. So that's going to be 500 minus, I'm going to go ahead and call that 5/2 x, less than or equal to y. All right. I really don't want to try to graph this, but I'm going to have to. Okay. So I'm going to go ahead and just do 1, 2, 3, 4, 5. I'm going to count that in the hundreds here. We'll see what happens. And then we'll do 1, 2, 3, 4, 5 by the hundreds. So if I'm at 200, I'm going to go down 100, run 200. Down 100, run 200. A little off there, but this will work. And we've got to be less than, so we're going to go down. Okay. Then 500, which is here, I'm going to go down 5. 1, 2, 3, 4, 5, run 2. And I'm going to get this. So again, I just found my y-intercept, and I'm treating these in hundreds because It's going to work if I go down 5, run 2, 5, 2, 5, 2. Down 500, run 200. Same thing, right? Yeah? Okay. And I'm going to shade below, so it's this side. So we're going to get this little space here. So we've got 4 corners. 1, 2, 3, 4. All right, so these points, obviously we have 0, 0. It's not going to make as much money if we sell 0 gallons. Okay, and okay, here we have 1, 2. So I'm going to sell 0, 200. Then I'm going to sell 1, 2, 1, 2, 200 and 200. And then this guy is 0, 300. No, this one seems like a different number. Down 1, run. Sorry. Down 1, run 2. So that's actually not 200 and 200. Sorry, that point's a little iffy, but it kind of looks like, let's say that this was 150 for Y. So I'm going to just try to figure out what that X value is. If that's 150, I'm going to take 500 minus 150, divide that by 2.5, that's 140. Let's see if that works up there. If I do 140 times 1.5 plus 150, those numbers don't work. Sorry, just trying to find that point here. What did I do again? So I said that's about 150 for Y, so 3 times 150, 600 minus that would be 100. So that's here. But if I do 2.5 times 100, that's not the 150 we did there. Okay, so I just want to know when these guys are equal. So I'm going to take my 1.5x plus 3y, and I'm going to set it equal to my 2.5x plus y. Or we could do the elimination that we did earlier, or I could quick graph it. Let's do a quick graph. So I've got my 200 minus 1/2 x, and I have my 500 minus 5/2 x. I'm going to go ahead and graph that. Zoom out. Okay, so I'm going to make my window go from 0 to 500 and 0 to 500. Graph that. Boom, I like that. Looks pretty. Check that out. That's what we're looking at. So now I'm just going to go ahead and ask this to find me my intersection here. Okay, I was close. Okay, so this intersection is at 150 and 125. All right, so if you remember, we converted this all to quarts, and then we're selling by the gallon. So we're going to have to go ahead and convert this into gallons to find our maximum. So this one I can say we're not going to do good here. Converting this to gallons, divide that by 4. That's going to give us how much money there. So we're going to take our 50 times 0.4. So this guy's going to raise us $20. Okay, 150 divided by 4. Then we're going to times it by 50 cents. And then plus 125 divided by 4 times 0.4. So these are going to give us the 31.25. And then the 300 divided by 4 to turn it into a gallon, times that by 0.4. And here we're going to get 30 bucks. So here we're going to get our most money if we make 150 quarts and of orangeade and 125 quarts of berry fruity. Okay, so again, we have to be very, very cautious here when we're finding those points, making sure we're getting those right values. So that one took a little bit of work. I resorted to my calculator just to make sure I found those points properly. Okay, but again, what we're looking for is what are we trying to maximize or minimize? What are our constraints and where do they intersect? Okay, good luck. If you have questions, let me know. Mel out.